Hello guys, Breeze is back. Today I'll be explaining about one Leetcode problem which is called sliding window maximum. Which is finding the maximum value of each subarray of size k. So let's double down and try to understand what the problem is. So for example, right? Suppose our array has 4 items. 2, 4, 2. In these 4 items, we'll try to find the maximum value in each subarray of size 2. So k becomes 2. So in this problem, we'll try to find the maximum value of each subarray. So in this subarray, the maximum value is going to be 2. In this subarray, the maximum value is going to be 4. And in this subarray, the maximum value is going to be 4 as well. So from these relations, what we can know is the number of subarrays is the total number of the arrays, which is 4, -2, plus 1, which is going to be 3, which is the number of these subarrays. So this is one logic we're going to be using in the future. So in order to solve this problem, there is 2 methods. One is going to be using the naive approach, which is we don't care about the time complexity and space complexity. We just trying to brute force and solve this problem. Yes, I think I forgot the A. And the second one is called a better approach, which is the expected approach. For the naive approach, we use two arrays, and we just trying to like loop through each item. So in this array, the first array is gonna be 1 and 2, and then we're gonna loop over that array in order to find the 2. So in this example, in the first array, I choose this window and I just loop over to find 1 and 2. And then for the next array, I still loop through it, and then I'm trying to find the maximum number through this loop. And then we do the same thing for the rest. We go through this array and we try to find the maximum value. So the problem was, so the naive approach is going to be using I and j, which is the nested loop. So the problem was this approach is the time complexity becomes O of n times k. So it becomes very expensive. It depending on the k, depending on the amount of subarrays we have to iterate through the size of subarray, we have to iterate through the main array. So it becomes, for each subarray we still have to loop through them. So that's why it becomes O of n times k, which is the time complexity. So the expected approach is gonna be we're gonna be using which method do you think? The sliding window maximum. So we're gonna be using the sliding window method. So instead of just looping through each separate, what we can do is we're gonna make a window and we're gonna slide down that window. And then in different array, we're gonna be storing the maximum value. So for this approach, I'm gonna be using sliding window maximum. And surprisingly, for this, the time complexity becomes O of n because it is a linear search approach, and then you're just sliding down the window. So time complexity becomes O of n. So as we have found the right approach for the problem, we'll be writing code for this approach. Not just so let me rewrite the array, which is going to be 1, 2, 4, and 2. So in this array, we have to create the first window. So in order to we have this size, right? K equal to n, k equal to 2. For this window, we have to. There's gonna be two things we're gonna be needing. The first one is DQ, which is the double-ended array. It is for this problem we'll be using Python. For DQ, what's good about this array is that in this array you can add items from the start and then you can remove items from the start, and you can do the same thing with the end of this as well. So we're gonna be using DQ in order to track the index of the maximum numbers. In this array, for the first window, 2, right? So we're gonna be tracking 1, the index 1 in this DQ. For the second one, the maximum number is 4. So we're gonna be tracking 3 in the DQ. For the last one, we're still gonna be tracking 3 in this. We're still gonna be tracking 2 in this DQ. So let's focus on the first window. For the first window, what we can do is we can for loop the array for I in range k. So k is going to be the end of the first, k is 2, so this is going to be excluded. We're going to be focusing on the first 2 array items. For each item in this array, we're going to be checking if the current one is greater or less than the previous one. Okay, I think we have to store the first one first in the DQ. So in the DQ, we're going to be initiating with the DQ, which is we get it from the Python library. We can use from collections import DQ, and then what we will be doing is we will store the first index. Regardless of the number's value, we have to store that because we're going to be using that to compare with the other ones. So in this for loop, what we have to change is we have to change the parameters. So instead of just including the ending point, we're going to be also including the starting point. Since we'll be excluding the first index, we'll be starting from 1 to k. This is a little bit hard. Okay, from 1 to k, what we can do is we're gonna be comparing. So this is the name of the original array. So we're gonna be checking if array of current item is greater or equal to oh my gosh. Greater or equal to the array's values using this index dq of 0. So if it is greater, we're going to compare it like that. If it is greater than the previous one, what we want to do is we're going to be, so in the dq, right? This is dq and this is the array. So all it has going to be 0 because it just blindly store the first index. So what we are saying is if 2 is greater than 1, what we're going to do is we're going to pop the index from the dq. So dq.pop. When we pop it, we're going to just remove that one. And then I should have some index here. Yeah, this is, if it is large enough, it's dq.pop. Do that. And then pop, and after that, and then we have to append this index, so which is 1, right? Which is 1, which is I, but we just paste dq.append the I. So regardless of this condition, we still have to append that number, because suppose like if it is like 1, if it is 1 and 1, so what we want to do is we still want to store the index of this one in the dq, right? And for example, if it is becoming 0, we still want to append this 0's index in the dq, because if you don't store it for the next, suppose like this is popped, then this value becomes a candidate for the max value for next subarray. So unless the value is greater than the previous one, we still have to keep it. If it is like decreasing, we still have to keep it in the dq. That's how we keep track of numbers for the next subarrays. Alright? Since we are clear on that, we can move on to the code. So we dq.append, and then what it's gonna do is this code is gonna iteratively store the index of dq. So in this case, only 2's index is stored, which is 1, right? So at that point, we have to save the maximum number of this subarray. What we can do is we can create a new array, which is result, right? So now result is going to be storing all the maximum values. So after this iteration of the first window, we're going to be appending into the result. So append, and every single time we're going to be storing the first value of dq. Remember, dq only stores the indexes of the maximum to the minimum. So it is always decreasing. So in order to get access to the maximum value, you have to reference the first index. That's why we always append the DQ 0. Oh no. So we also have to reference the array, right? Reference the array item. Reference the array item, so which is gonna be from array DQ 0. Remember, this is the index number. That's why we use that. Okay, after the first array, we can now slide down. Alright? In order to slide down, we have to start from K, right? This is K is 2, 0, 1, 2. So this is gonna be starting from we will be starting from this K up until N. Alright? Up until N. But the window's still gonna be starting from the second index, which is 1, 2, 4, right? So for this, we're gonna be using the for loop again. Don't worry, this is using, even though they are using 2 for loops, they will be the same number of like space complexity, because we are doing the linear algorithm. So the space and time is going to be the same. So for I in range, so this one we're going to be starting from K up until N. So in this one, what we can do is we're going to be comparing this. We're going to be comparing this. Let me see. So in this new window, what we're gonna be doing is we're gonna be comparing the value, the current item's value, comparing with the value in the DQ. So first, what we have to do is we have to check if that index is still within the window. They're still within the window. If it is outside of the window, we don't want to compare it, right? Because like, for example, right, in this window 2 and 4, we're only gonna be comparing with 2. We're not comparing with the 1, right? Because it is outside of window. We don't care about that. So in this case, we're gonna be checking. We're gonna be checking if there is still DQ. DQ, I mean like if there's still if there are items still in the DQ, and this is for the safeguard, and we're gonna be checking if the DQ dot 0, the index position, if DQ dot 0 is less than or equal to the window, which is for this one, the current index is 3. 3 negative 2 is gonna be 1, right? If it is 1, we not gonna include it. So this is gonna be I negative K in order to see if it is still in the current window. If it is less than or equal to this value, what we're gonna do is we're gonna pop that value. We're gonna pop this value. So what we're gonna do is DQ dot pop left. In this case, pop left is removing the first leftmost value. So this is gonna be popped. Yes, and And then now we can compare it. Oh no, I feel like 1. Huh. Ah yes, that was my fault. This one indicate that 0 and 1 will be in the DQ. So what we can do is we can just write 0 and 1, which are the we just write 0 and 1, which are the indexes of the numbers, right? Now according to this code, we can remove this one. We can remove the 0. So for the 1, we check it I negative k, which is going to be 2, negative 2, it's going to be 0, 0, but this one is greater than 0, so this is not solved. Now what we're going to actually do is we're going to accept this one, and now we're going to be comparing the current value with the with the highest value from the DQ. So while DQ and in the array, we're gonna be comparing with the current value. If the current value is greater than the value that is referenced by the DQ, what we're gonna do is we have to pop the value, pop this index, and replace it with the higher values index. So if index I is greater and equal to, we're still referencing in the initial array using the last index of DP, last value of DP. Now after comparing that, 4, we're going to be comparing 4 with 2. 4 is really greater than 2. That's why we're going to DQ dot pop. We're going to pop the last item, which is 1. We're going to be popping that, and then regardless of everything, we're going to be DQ dot append. What we're going to do is we're going to be adding that index to the DQ, which is 0, 1, 2, 2. Now 2 is here, and then at the end we have for this first loop we have come with the conclusion of having index 2. 2 is referencing to the highest value of that separate. So what we have to do is we have to append that value into the result. Array. Remember, we're always using the first index because it is the maximum value. DQ 0. Yes, sir. Now we're gonna be going into the same loop again, which now we're gonna be stepping into 0, 1, 2, 3, 3. So while DQ is still here, and then DQ 0 is less than a DQ of 0. Oh yeah, this index, if that index is still, we're gonna be checking if that index is still in the window. So 2 is 2, this is 2, I negative k, I is 3, negative 2, 3, negative 2, 1. So 2 is absolutely greater than 1. That's why we are not popping the left, right? Because yeah, it also follows our same terminology. We're gonna be storing the maximum values to the minimum values. It's gonna be decreasing. We're not excluding the lesser value because we will be using that in order to compare with other values in the next step array. We don't want to lose that. All right, so we're not popping it. And then for the next one, we check DQ, and then we're gonna be comparing the current value to with the maximum value from the previous the maximum value from the maximum value in the context window, because after we checked it is still in the context window, we're gonna be using that in order to find the maximum value. So 2 is greater than 4. No, it doesn't, it's not true, right? 2 is less than 4. That's why we're not popping. We're not popping. And then what we're going to do is we're going to be appending that I, which is size 0, 1, 2, 3. We're going to be appending this index. But the magic is, at this point, we're not displaying this index. We're still displaying this 2. So which is going to be 4. So our conclusion is going to be 3 items array. The first one, that's pretty obvious, which is 2, 4, and 4. That's the end of our problem, and hope you guys enjoyed it. And yes, I'll be explaining these computer science concepts and backend engineering technologies. Stay tuned. Peace out. Breeze us out.